robotics that's usually the representation of that. But that's not at all true. Everything is going to be robotic. All of the factories will be robotic. The factories will orchestrate robots, and those robots will be building products that are robotic. Robots interacting with robots, building products that are robotic. Well, in order for us to do that, we need to make some breakthroughs, and we should be video.
The era of robotics has arrived. One day, everything that moves will be autonomous. Researchers and companies around the world are developing robots powered by physical AI. Physical AIs are models that can understand instructions and autonomously perform complex tasks in the real world. Multimodal LLMs are breakthroughs that enable robots to learn, perceive, and understand the world around them and plan how they'll act. And from human demonstrations, robots can now learn the skills required to interact with the world using gross and fine motor skills. One of the integral technologies for advancing robotics is reinforcement learning. Just as LLMs need RLHF, or reinforcement learning from human feedback, to learn particular skills, generative physical AI can learn skills using reinforcement learning from physics feedback in a simulated world. These simulation environments are where robots learn to make decisions by performing actions in a virtual world that obeys the laws of physics. In these robot gyms, a robot can learn to perform complex and dynamic tasks safely and quickly, refining their skills through millions of acts of trial and error. We built NVIDIA Omniverse as the operating system where physical AIs can be created. Omniverse is a development platform for virtual world simulation, combining real-time, physically based rendering, physics simulation, and generative AI technologies. In Omniverse, robots can learn how to be robots. They learn how to autonomously manipulate objects with precision, such as grasping and handling objects, or navigate environments autonomously, finding optimal paths while avoiding obstacles and hazards. Learning in Omniverse minimizes the sim to real gap and maximizes the transfer of learned behavior. Building robots with generative physical AI requires 3 computers, NVIDIA AI supercomputers to train the models, NVIDIA Jetson Orin and next generation Jetson Thor robotic supercomputer to run the models, and NVIDIA Omniverse, where robots can learn and refine their skills in simulated worlds. We build the platforms, acceleration libraries, and AI models needed by developers and companies, and allow them to use any or all of the stacks that suit them best. The next wave of AI is here. Robotics, powered by physical AI, will revolutionize industries.
This isn't the future, this is happening now. There are several ways that we're going to serve the market. The first, we're going to create platforms for each type of robotic systems. So one for robotic factories and warehouses, one for robots that manipulate things, one for robots that move, and one for robots that are human. And so each one of these robotics platforms is like almost everything else we do. A computer, acceleration libraries, and pre-trained models. Computers, acceleration libraries, and pre-trained models. And we test everything, we train everything, and integrate everything inside Omniverse, where Omniverse is, as the video was saying, where robots learn how to be robots. Now, of course, the ecosystem of robotic warehouses is really, really complex. It takes a lot of companies, a lot of tools, a lot of technology to build a modern warehouse. And warehouses are increasingly robotic. One of these days will be fully robotic. And so, in each one of these ecosystems, APIs that are connected into the software industry, SDKs and APIs connected into edge AI industry and companies, and then also, of course, systems that are designed for PLCs and robotic systems for EOQs. It's then integrated by integrators created for ultimately building warehouses for customers. Here we have an example of Kenmac building a robotic warehouse for a giant group. And then here, now let's talk about factories. Factories is a completely different ecosystem. And Foxconn is building some of the world's most advanced factories. Their ecosystem, again, edge computers and robotics, software for designing the factories, the workflows, programming the robots, and of course PLC computers that orchestrate the digital factories and the AI factories. We have SDKs that are connected to each one of these ecosystems as well. This is happening all over Taiwan. Foxconn is building digital twins of their factories. Delta is building digital twins of their factories. On the way, half is built, half is on the list. Megatron is building digital twins of their robotic factories. Wistron is building digital twins of their robotic factories. And this is really cool. This is a video of Foxconn's new factory. Let's take a look.
Demand for NVIDIA accelerated computing is skyrocketing as the world modernizes traditional data centers into generative AI factories. Foxconn, the world's largest electronics manufacturer, is gearing up to meet this demand by building robotic factories with NVIDIA Omniverse and AI. Factory planners use Omniverse to integrate facility and equipment data from leading industry applications like Siemens Teamcenter X and Autodesk Revit. In the digital twin, they optimize floor layout and line configurations and locate optimal camera placements to monitor future operations with NVIDIA Metropolis-powered Vision AI. Virtual integration saves planners on the enormous cost of physical change orders. During construction, the Foxconn teams use the digital twin as the source of truth to communicate and validate accurate equipment layout. The Omniverse digital twin is also the robot gym, where Foxconn developers train and test NVIDIA Isaac AI applications for robotic perception and manipulation, and Metropolis AI applications for sensor fusion. In Omniverse, Foxconn simulates 2 robot AIs before deploying runtimes to Jetson computers. On the assembly line, they simulate Isaac manipulator libraries and AI models for automated optical inspection for object identification, defect detection, and trajectory planning. To transfer HGX systems to the test pods, they simulate Isaac Perceptor-powered Ferrobot AMRs as they perceive and move about their environment with 3D mapping and reconstruction. With Omniverse, Foxconn builds their robotic factories that orchestrate robots running on NVIDIA Isaac to build NVIDIA AI supercomputers, which in turn train Foxconn's robots.
So, a robotic factory is designed with 3 computers. Train the AI on NVIDIA AI. You have the robot running on the PLC systems for orchestrating the factories. And then you, of course, simulate everything inside Omniverse. Well, the robotic arm and the robotic AMRs are also the same way, 3 computer systems. The difference is the 2 Omniverse systems come together. So they'll share one virtual space. When they share one virtual space, that robotic arm will become inside the robotic factory. And again, three computers, and we provide the computer, the acceleration layers, the